to a sheep. Welcome back to our classroom. Today I'll be teaching you about electrolysis. Electrolysis is the process of using electrical energy to break down ionic compounds. It converts electrical energy into chemical energy. It requires an electrolyte, a molten or dissolved ionic compound with mobile ions, which means that it needs an ionic compound that has ions that are moving inside it. Electrodes are two rods on either end of the electrolyte that are electrical conductors that are immersed into the electrolyte. The positive electrode is called the anode, where oxidation occurs. The negative electrode is the cathode, where reduction occurs. Now I'll tell you about the components that you need to perform electrolysis. You need a power supply. This should provide a direct current that is necessary for the non-spontaneous reaction. You need, obviously, two electrodes, an anode and a cathode. Typically, they should be made of inert materials like graphite or platinum, providing a service for electrons transfer. You need an electrolyte as well, the substance containing free-moving ions, either molten or in an aqueous solution. You need ion movement with a cation, which moves towards the cathode, and anions that move towards the anode. Even though the cathode is the negative electrode and the anode is the positive electrode, they are called the opposite names because it is easier for you to remember. So the anions go to the anode and the cations go to the cathode. Even though the cations are positive, they go towards the negative electrode because opposite forces attract, and same goes for anions and the anode. Now I'll teach you the process of electrolysis of molten ionic compounds. And for this example, I'll teach you about molten lead to bromide. In its molten state, Pb2 plus and Br negative ions are free to move. At the cathode, lead-2 ions gain electrons from reduction to form molten lead. At the anode, the positive electrode, bromide ions lose electrons from oxidation to form bromine gas. The overall reaction is called PbBr2, which is a liquid, becomes Pb plus Br2. You should observe that a silvery liquid, which is lead, forms at the cathode, and a reddish-brown gas, bromine, forms at the anode. Now I'll teach you about the role of water during electrolysis of aqueous solutions. When an ionic compound dissolves in water, the solution contains its own ions plus hydrogen ions and hydroxide ions, OH negative, from water dissociation. This introduces competition among ions at both electrodes, making product prediction a bit more complex. The reactivity series is crucial for determining what is discharged at the cathode. The presence and concentration of halide ions also affect the product formed at the anode. Now I'll teach you about the rules for how to predict the product at the cathode. Positive ions, H plus and metal ions, are attracted to the cathode. The rule is the less reactive ion will be discharged, which means gained electrons, or also known as being reduced. If the metal in the ionic compound is more reactive than hydrogen, for example, sodium, potassium, magnesium, aluminum, then hydrogen gas will be produced. If the metal in the ionic compound is less reactive than hydrogen, then the metal itself will be produced in solid form. Now I'll teach you about the rules to predict the product at the anode. Negative ions, OH negative and other anions, are attracted to the anode. The rule is that the ion that is more easily oxidized, which means losing electrons, will be discharged. If halide ions, chloride negative, bromine negative, iodine negative, are present in a concentrated solution, the halogen, for example, chlorine or bromine, will be produced. If no halide ions are present, or if the halide solution is dilute, then Oxygen gas from hydroxide ions will be produced. Sulfate and nitrate ions are generally not discharged at all. Now I'll teach you about the things you can do with electrolysis. You can extract reactive materials. You can extract reactive metals. Electrolysis is used to extract metals more reactive than carbon, for example, aluminium or sodium, from their molten ores. Electroplating, coating a cheaper metal with a thin layer of a more expensive or corrosion-resistant metal. For example, silver plating for cutlery or chrome plating car parts. Or you can also use electrolysis for the purification of metals. You can refine impure metals to obtain high purity metals, for example, copper refining, because in the case of copper, the more impure it is, the less electrically conductive it is. So people tend to want to buy purer coppers. You can also use electrolysis for the manufacturing of chemicals. Production of important industrial chemicals such as chlorine, sodium hydroxide, and hydrogen can be made from electrolysis. Now, I'll give you an example about the electrolysis of the aqueous solution copper 2 sulfate. The ions present are Cu2+, which is aqueous, SO42 negative, which is aqueous, H+, which is aqueous, and OH negative, which is also aqueous. At the cathode, copper ions, Cu2+, are less reactive than hydrogen ions, H+. The product is copper metal, a pink-brown deposit. At the anode, sulfate ions, SO42-, are not easily oxidized. Hydroxide ions, OH negative, are discharged. The product from this is oxygen gas. The overall reaction is 2 CuSO4 aqueous plus 2H2O, which is a liquid, becomes 2 Cu, which is a solid, plus O2, which is a gas, plus 2H2SO4, which is aqueous, which means that sulfuric acid forms as well as oxygen gas and copper as a solid. Now I'll give you another example of electrolysis of concentrated aqueous sodium chloride. The ions present are Na+, which is aqueous, Cl negative, which is aqueous, H+, which is aqueous, and OH negative, which is aqueous. At the cathode, sodium ions, Na+, are more reactive than hydrogen ions, H+. The product is hydrogen gas. At the anode, due to the high concentration of chloride ions, Cl negative, they are discharged over hydroxide ions, OH negative. The product is chlorine gas. The overall reaction is 2NaCl, which is aqueous, plus 2H2O, which is a liquid, becomes 2NaOH, which is aqueous, plus H2, which is a gas, plus Cl2, which is a gas as well, which means that sodium hydroxide forms as well as hydrogen gas and chlorine gas. Now, I'll give you some questions to test how well you understood what I just taught you. Number 1, explain why solid ionic compounds do not conduct electricity, but molten ionic compounds do. I'll give you a hint. Consider the mobility of the ions. The answer is, in solid ionic compounds, ions are held in a fixed lattice position and cannot move to carry charge. In molten ionic compounds, ions are mobile and are free to move, allowing them to conduct electricity. You should have learned this by now, but ionic compounds are only conductive when they're molten. Number 2, predict the products at the anode and cathode when dilute aqueous potassium iodide, Ci, is electrolyzed using inert electrodes. I'll give you a hint. Apply reactivity series and anion discharge rules. The answer is, the ions present are K+, which is aqueous, I negative, which is aqueous, H+, which is aqueous, and OH negative, which is aqueous. At the cathode, hydrogen gas, H2, is produced because potassium is more reactive than hydrogen. At the anode, iodine, I2, is produced because iodide ions are more easily oxidized than hydroxide ions, even in a dilute solution. Now, I'll give you another question. Number 3. During the electrolysis of molten aluminum oxide, what is formed at the cathode? I'll give you a hint. Identify the cation present and its behavior. The answer is aluminum metal, Al, is formed at the cathode. And that is it for today's video. Please like and subscribe if you learned something new. 3, 2, 1.